All right, hi everyone. Sorry I can't be in class today. Um, Today we are solving radical equations. So I'm going to make a brief video that goes through each type of example, and then you'll have the rest of the period for work time. All right, so a radical equation is an equation in which a variable is under a radical or raised to a rational exponent. So when we're solving radical equations, first thing we want to do is we want to isolate the radical. That means get the radical by itself. Then, once it is, we can raise each side to the reciprocal power. So if we have a square root, we raise it to the second power. If we have a third root, we raise that to the third power. If we have a cubed root of something squared, we would raise that to the 3/2 power, etc. So raised to the reciprocal root. Once you do that, solve for the variable, and then don't forget to check for extraneous solutions. So let's look at example number 1. So first step, I want to isolate my variable. So my radical. Add 4 to both sides. I get 2 times the square root of x plus 2 equals 10. Divide by 2. Square root of x plus 2 equals 5. And then square both sides. So we get x plus 2 equals 25. So I subtract 2, and we get x equals 23. Before we move on, square root have restricted domains. I'm taking an even root, so we want to verify that x equals 23 is not an extraneous solution. So when I'm checking, I substitute 23 back in for x. So I get 2 times the square root of 25 minus 4, which is 2 times 5 minus 4, which is 10 minus 4, which is 6. And that's what we wanted, right? We wanted this equation to equal 6. So we're good. X equals 23 is the solution. All right, the next equation that I'm going to solve is number 3, and this is just a little bit different because it's a cube root instead of a square root. But same steps. First, start by isolating the radical, so I'm going to get rid of the plus 2 by subtracting 2 on both sides. So now I have the cubed root of, oops, what just happened here? There we go. So now I have the cubed root of x on the left-hand side, and I have 2 on the right-hand side. And now I can raise both sides to the third power because remember, the cubed root of x is the same thing as x to the 1/3. So the reciprocal of 1/3 is 3. So I raise both sides to the third power. So I get x on the left-hand side, 2 to the third power equals 8. Now, cubed roots will not have extraneous solutions because cubed roots do not have restricted domains. But if you want to just get in the habit of checking regardless, because it is a good habit in general to check your answers, we can double check. Cube root of 8 is 2. 2 plus 2 is 4, and that's what we wanted. All right, example 5 is a square root equation, but this one's a little bit different because I can't isolate my square root, right? None of these square roots are like radicals, so I cannot isolate them. I can't add or subtract them together. So what you want to do when you have multiple radicals is you want to just choose a singular radical to isolate. So since the square root of 3x plus 5 is already isolated, I'm going to move on to step 2. I have a radical isolated. So now I'm going to raise to the reciprocal power. So I am now solving this with respect to the square root of 3x plus 5. So to get rid of that radical, I'm going to raise both sides. Let me erase that. To the second power, because the reciprocal of 1/2 is 2. Now the left-hand side, be careful. Remember, when you square something, it means to multiply it by itself. So when I have the quantity square root of 5 plus square root of x squared, I have to expand that out. Square root of 5 plus square root of x times square root of 5 plus square root of x. So we distribute on the left-hand side. Square root of 5 times square root of 5 is 5. Square root of 5 times x is the square root of 5x. X times square root of 5 is the square root of 5x. And x square root of x times square root of x is x. And now I have a brand new radical square root equation. So I'm going to restart my steps. Step 1, isolate my radical. So I can combine those like terms. I can add them together because they are like radicals. They're both square root of 5x. And now I want to isolate my radical. So get rid of the 5 and get rid of the x. So on the left-hand side now, I'm left with 2 square root 5x. On the right-hand side, just 2x. Divide by 2, and this worked out nicely. Square root of 5x equals x. And now I can raise both sides to the second power because the reciprocal of 1/2 is 2. So we get 5x equals x squared. And now this is a quadratic. So in order to hopefully factor, I have to get this equal to 0. Factor out the x. Now I can set each factor equal to 0 and solve. So we get 2 possible solutions, x equals 0 and x equals 5. And now I'm going to double check. Let's see, I'm going to check 0. Let's start there. Square root of 5 plus square root of 0 is square root of 5 on my left-hand side. On my right-hand side, I have the square root of 3 times 0 plus 5, which is the square root of 5. So this one works. And now checking 5, on the left-hand side, I have the square root of 5 plus the square root of 5, which is 2 square root 5. On the right-hand side, I have the square root of 3 times 5 plus 5, which is the square root of 15 plus 5, which is the square root of 20, which is 2 root 5. So both of these are solutions. All right, and the last example that we're going to do together is example number 9. So all of our other ones were written in radical form. This is written in exponent form. So I am going to raise both sides because my radical's already isolated. So I'm going to raise both sides to the 2/5 power. So my left-hand side, properties of exponents, a power times a power, you multiply, or power raised to a power, you multiply. So I end up getting x squared plus 5x plus 5 to the first power. Right-hand side, 1 to any power is just 1. So that ended up working very nicely. Now this is a quadratic, so I'm going to get this equal to 0 so I can hopefully factor. And this does factor nicely to be x plus 4 times x plus 1. So I set each factor equal to 0. And I get 2 possible solutions, x equals -4 and x equals -1. And now we're going to double check. Are they both solutions? Because this is a square root, so it is possible that I might have an extraneous solution. So when I substitute in -4, let's see, that's -4 squared plus 5 times -4 plus 5, so that's 16 minus 20 plus 5, which gives us 1. So that's what we want. And then when I check -1, I get -1 squared plus 5 times -1 plus 5, which is 1 minus 5 plus 5, which is 1. So both of these are, in fact, solutions. All right, so that is our lesson for today. We went through one of each type of example. If you are looking for some extra practice before you start the homework, go ahead and do any of the problems from the notes that we did not have time to get to in this video. And then the filled in notes are on Classroom, so you can pull up the solutions to check to see if you got it right. Otherwise, if you're feeling good about this, feel free to get out your homework. It is a worksheet, and use the rest of class time to work on your homework. All right, I hope you enjoyed this video, and I hope you all have a wonderful Halloween, and I will see you all tomorrow.